And welcome to the Daily Space Weather. I'm your host, Dan, aka Smash-O-Mash, and this is a 24-hour video of the closest star. So far, no CME strike as anticipated. We'll see what happens. Could it be that I was incorrect? It does occasionally happen, by the way, and our record isn't too far off from NOAA, NASA, ESA, etc. So everybody has a pretty similar statistical record with these sorts of things. Sometimes we miss it, sometimes we get it, sometimes they miss it, sometimes they get it. Facts. So it's always good to be wrong in anything if you learn something from it. This time I didn't learn much because there wasn't a lot to see in terms of data showing us the CMEs are on the far side. So I still say there's one on the way. It's just more slowly moving than I anticipated. That's the best guess. There's SDO for the past 24 as well. 304 angstroms. We got a bunch of new sunspots. Sunspot number here coming back above the average right now. So we'll be pulling the average up starting tomorrow. Also an increase in the radio flux and so forth. So, by the way, if you enjoy the content, don't forget to press the like button. Tell your friends and foes about the channel by pressing share. And if you're new to the channel, press subscribe. Otherwise, you won't be able to see the world's most comprehensive daily space weather content without having to search for it. So, yeah, thanks to everybody who supported the channel. And let us be the first to say happy summer. We shot this video only about 15 minutes, only about the 19 minutes before the solstice. So congratulations on surviving another spring if you're from the northern hemisphere, or another autumn if you're in the southern. Happy summer, happy solstice, happy whatever you want to say. The radio flux now up to 196 solar flux units, 196. And there it is depicted over the past year. So the black line there, you can expect to see this rising higher and higher as we're, still got another 3 to 4 months until solar maximum, so expect higher highs and higher lows. Space Weather Enthusiast Dashboard. That's NOAA's space weather forecast, and they are expecting some geomagnetic unrest early in the morning on Saturday the 22nd. So Saturday the 22nd, some geomagnetic unrest there. I believe it is from a coronal hole high-speed stream. Let's see. What's it showing on here? Looks like a coronal hole high-speed stream. I don't know. I'm not so sure. Yeah, it could be. Could be that. And it looks like that's what ESA is forecasting as well. So European Space Agency. The top depicts the plasma density. The bottom depicts the plasma velocity. Looks like they're expecting coronal hole high-speed winds in just a couple of days. So no arguments there. Here are the past 4 hours of Earth's magnetic moment from space. That is our Geospace Magnetosphere movie. And yeah, geomagnetically calm, a lot more geomagnetically calm than we expected going into today's video. So, but if the CME arrives later than expected, that's good for us, because if it happens around dusk, then we're a lot more likely to be able to see the aurora here in Lehigh Valley, Pennsylvania. Here are the past 4 hours of Earth's magnetic moment from ground level, our ground magnetic perturbations map. This depicts magnetic flux density, and things, like I said, are pretty chill. So no space weather storms at the moment, but we are still expecting one. A mild G2 class geomagnetic storm of the KP6. Current average of global geomagnetism is 1.33, KP 1.33. So that is quite geomagnetically calm indeed. So yeah, no CME impacts yet. Current conditions are waning from yesterday. So those are the measurements from ACE located at Lagrangian point 1. We'll call out the numbers for Discover. About 6.5 protons per cubic centimeter for the density. Solar wind velocity still over 450 kilometers per second. Gauss magnetometers are smooth. Electron flux is much higher than we expected. We'll get to it in our bonus features segment. First, some data about the heliosphere. And Earth has just snapped into a North Pole-oriented magnetic sector. So as you can see there, depicted in green, Earth now in a North Pole-oriented magnetic sector. I'll bring up the last image for your convenience. There you go. North Pole. Welcome to summer and welcome to the North Pole magnetic heliospheric sector. Here is our line of sight field plot. Polar fields depicted in red and green for south and north, respectively. Blue lines are the potential field surface source lines for the solar B field, that being the field that goes through the magnet, and then the photosphere, the portion of the sun where sunspots occur, depicted in grayscale. 4 days, a lot of info, all packed into one series of frames. Next is coronal holes. And they must be expecting that northern heliographic South Pole-oriented coronal hole there, shown in red, to be geo-effective. I think that'll miss Earth, so some more disagreement in the space weather forecasting ranks. But that's what you want, because we'll say thanks if we're right. So yeah, that's what's going on there for coronal holes. We've got all northern ones except around the north heliographic polar region. Let's take a look at those from SDO. We've got some interference going on here, some missing frames or some packet loss or something like that happening there from SDO, it looks like. So this is in most of the data that we'll be showing. It was an unavoidable series of things. So yeah, sunspot number here now just under 160. About 160 sunspots, and that's now make it 158. 158. The average is 159. So, but there are some uncounted sunspots. So tomorrow we'll see that rise. So 3719 and 3720 got names, but 3721 not named yet. So that could be as many as 20, 30, 40, 50 more sunspots. Sunspot number will be approaching 200 here. Also, as those sunspots, especially 3713 and 3712, especially 3712, as it approaches the limb, its likelihood to produce an X-class flare actually goes way up. Look at that. It's got a 2 out of 3 chance of producing an X-class flare there on the flare probabilities, the flare probability monitor there. Check it out. 66%. For sunspot 3712. So it remains the T-mass. It is still our most active sunspot. Let's take a look at sunspots here from SDO. There you go. There's the continuum. And we won't worry about any zoom-ins today. But just keep in mind, there is a very high likelihood of large flares. The magnetic complexity of those new sunspots there on your screen left, which would be the eastern portion of the closest star, they're not as magnetically complex as especially 3712. But it's been holding pretty steady here. But don't let that lull you into a false sense of it's not going to flare, because the flare probability goes up just due to the proximity to the limb. Yes, sunspots flare more and flare bigger when they're close to the limb. There's magnetogram. And of course, the most important sunspot to watch would be 3712, which would be your lower right. And it has gained a little bit of complexity there, but it's mostly stable for the past 24 hours. Yeah, some promising magnetic shear over there on the east from that southern sunspot group. 3719, I believe that one is. So those are the two, I think those are actually the two most likely to produce large flares. But let's move on to energetic particles and flares. It has been calm. No spikes in the proton flux, so no energetic particles. The likelihood of that's going up as those sunspots approach the limb as well. And we did have only one M-class intensification for the past 24 hours. Let's take a look at it from the perspective of 94 angstroms SDO. And I think that M-class event actually came from one of those eastern groups. 3719 down there in your lower left. Some heavy activity up there behind the northeastern limb as well. You can see up there a lot of brightening, a lot of, there was a CME, and it looks like probably a large flare. Not going to be earthly directed. But let's move on here to show the solar system forecast. Yes, solar system forecast time. There you go. That's where things are today. And once again, happy solstice. That's where things will be in 1 week. We will still have a gibbous waning moon. Next, a star chart. And if you've got a low horizon, you might be able to see the dog star. No, maybe not. It'll still be up when the sun is up. So Sirius is going to be rising. The sun and the moon are rising and setting at the same time, by the way. So the moon's rising right as the sun's setting tonight. So that might make for some nice lunar viewing for you. You can see right as the sun sets, the moon rises. And then tomorrow morning you'll see Saturn, Mars, Jupiter. All right, anyway, that's what's currently going on over our head at our location. That's skyandtelescope.org. Astronomy photo of the day is a 22-degree moon halo caused by ice crystals refracting light, the same thing that makes a sundog, essentially. And, yeah, there it is. It's not chemtrails, it's not contrails, it's not stratospheric, and it's not geoengineering, it's not solar radiation management, it's not a campaign of spraying chemicals out of planes. It's cirrus clouds. Cirrus clouds and moonlight and a relatively homogeneous atmosphere. Those are sort of the things that you need to see a halo like that. You can check it out yourself if you like at apod.nasa.gov. apod.nasa.gov. So moving on to CMEs, and we have had some. They just aren't earthly directed, so we won't spend a whole lot of time on those. That's 83 frames from today from George Mason University, complete with difference imagery on the left. LASCO C2 and C3 here. Let me move the C3 up a little bit to speed things up. Not so exciting. We'll also show stereo A, which is located where that little red dot over there is located. It's gaining more and more angle on Earth, so that's a good thing. It'll help us to be able to forecast the earthly directed or far side coronal mass ejections and so on. And there's the view from stereo A. Let's get this a little bit further forward here. I'll just move this ahead manually. So there's today. And it's been pretty quiet as far as CMEs go. Let's check out our custom coronagraphs next. Yeah. So yeah, those custom synced coronagraphs are pretty good, right? But yeah, not those. We don't see any indication that there are earthly directed CMEs. Now we do have that massive plasma filament dubbed the Michael Jordan filament right in the center of the solar disk right now, and it's gonna have the possibility of creating earth directed CMEs for a long time. You can see that dark absorption feature kind of draped across the center of the solar disk down to the lower left. That's the Michael Jordan filament, one of the largest ones in the past 6 years. So that's an exciting filament, especially if it does release. It will create a spectacular coronal mass ejection. Maybe a series of Hyder flares associated with it, who knows? But you'll know if you watch the channel. So next are filaments. And let's show the SDO imagery first. There you go. There's a great view of filaments. You can see that extremely dark absorption feature there right across the center disk, just south of the equator. That's the Michael Jordan filament. It is indeed an impressive specimen. All right, so filaments. There are filaments from Cerro Tololo. Great view of them. Quite a few very dense, well-defined filaments there at the moment. No less than about a half dozen on the Earth side of the disk. And we expect more to be rising soon, as there is certainly a bunch of activity there about to rise over the northeastern limb. So that's pretty sweet. There's the grayscale imagery. Not bad. Before we get the bonus features, here are the past couple of hours from GOES 16 SUVI. Yeah, so a bit of an uptick here since yesterday. The likelihood of large solar flares remains quite high. Here come bonus features starting with satellite charging hazards. We don't have any. It's smooth sailing. The GOES electron flux here much higher than expected. We expected to see this dipped by now because of a CME impact, but no such luck yet. NOAA's forecast was extremely accurate. Mine yesterday was extremely inaccurate, so point taken. Next is our ionosphere map. We'll show the ionosonde. The F-flare is what we're showing. It's at about 300 kilometers of altitude, and there it is. And it should be snapping back to more normal here. So we should be seeing less low-frequency anomalies on that, at least by the end, I would think. And if that's completely arcane to you, then don't worry. The next frame will be the anomaly gram. There's the anomaly in megahertz from a 30-day median. Keep in mind, folks, that major geomagnetic storms are much less likely around the solstice, or a bit less likely around the solstice than around the equinoxes. The equinoxes are much more active geomagnetically speaking on Earth, that is for aurora, geomagnetic storms, and so forth, because of the Russell-McFerrin effect, where high-energy electrons are accelerated in the outer Van Allen belts. Next, the global ionosphere nowcast. It depicts the total electron content on the left and the maximum usable radio frequency on the right. For you GPS and radio operators. Yes, space weather. It affects your GPS. It affects your HF radio transmissions. Your GPS satellites are at about 12,500 miles of altitude, and the D layer of the ionosphere that reflects your radio transmissions are at about 80 kilometers of altitude. That's the D layer, about 80 kilometers. So here is the latest. All right, so let's take a look at these new sunspots first. That one looks like it's got some more activity trailing it, because so far that's looking weak. We've got some legit sunspots certainly behind the northeast limb yet, so you can expect sunspot number to rise going into tomorrow. We should have more new sunspots than we have setting sunspots. This group down here, 3719, is looking promising. 3712, still the most likely place. I think this one might have gained some magnetic complexity as well, but there you go. There are the views. That is a pretty busy solar disk. And we'll close out with, how about the GOES 16 SUVI? Yeah, there you go. It's the GOES 16 SUVI 131 angstroms wavelength. The past couple of hours there, some new activity kicking off. You can see some flaring there in your lower left. That's sunspot 3719. Anyway, it's time to close this thing out. Once again, happy solstice. We'll see you soon. Don't forget to press the things like comment, like, share, etc. Visit the links below the video. Perhaps pick up some Smash-O merch. And until next time, may that solar wind be at your back.